Model 79 is a full-function pipe weld head that features AVC or arc voltage control, oscillator, wire feed, and rotation. The Model 79 is specifically designed for pipe shop applications where low radio clearances are not necessarily the reigning criteria. The major advantage to the Model 79 is the quick mount and dismount feature and this clamping mechanism. The clamping mechanism is built integrally into the weld head. You can adjust for various different pipe sizes simply by rotating this knob here and moving the clamps in or out. The clamps allow you to center the pipe in the weld head, and it also allows the weld head to square to the joint. To mount the pipe or the weld head on the pipe, simply put it on, adjust for size, and clamp. Here we're watching an example of torch oscillation. As you can see, the weld head or the torch is moving across the weld. The time that we spend on the sidewalls is called dwell time. The time that we move across the center of the weld is excursion time. What this basically does is it emulates a manual welder's motions. For example, we can program or control the amount of time that we spend on the sidewall, just as a manual welder would tend to rest his torch on each of the sidewalls to allow the metal to fuse and then move rather quickly across the center of the weld. That's completely programmable in our case and completely repeatable each time. The next function that we have is arc voltage control, which essentially is a torch moving up and down, or the relationship between the torch and the actual weld puddle. The nice thing about TIG welding is there's an extremely dynamic relationship between arc voltage and arc length. This allows us to control the welding arc length by measuring the arc voltage and jogging either the torch up or down to match the preset value that we put in the program. This is done by this motion here. For example, if the voltage is too low, the torch will jog slightly upward, and if the voltage is too high, the torch will jog slightly downward. This happens continuously until the weld sequence is terminated. You also have control over your wire feeder. Your wire feed, or your filler material, is fed in through a nozzle that's attached to the torch here. Now, before the welder starts actually welding, or you initiate the welding sequence, you generally check and preset the relationship of the wire under the electrode and cross seam under the electrode. So you center the wire and you preset the length between the electrode and the top of the wire. The up-down motion of the wire is controlled here, and the cross-seam motion is controlled here. Now, these are adjustments that can also be made during the welding sequence. The last and final function that we have is, of course, torch rotation. In most cases with cold wire TIG, the progression of the weld is towards the wire feed. And we can also synchronize any of these functions, including rotation, with our current pulsation. For example, when we go to a high current, we can feed a higher rate of wire, spend a lot more time on the sidewall, and as we move across the center of the weld, we feed less wire, and we maybe go to a low current condition and maintain better puddle control. And it's generally a good idea to pre-wrap the cable before we actually start welding. This allows the cable to not get bound while the weld head is operating. In order to do that, we have a clutch that we push here. And all you do is you simply rotate the weld head around the part to your actual start position. We're now ready to weld.